AIC rating refers to the ampere interrupting capacity of a circuit breaker. This rating indicates the maximum fault current, in amps, that the circuit breaker can safely interrupt without failing. It's a crucial parameter for ensuring electrical safety, as it determines the breaker's ability to clear a short circuit or ground fault. A higher AIC rating means the breaker can handle more severe fault conditions. However, having a high AIC rating doesn't automatically mean the breaker is also switch duty rated. Switch duty rating, on the other hand, specifies the breaker's capability to repeatedly switch normal load currents or even moderate overloads without experiencing excessive wear or degradation of its contacts and operating mechanism. This is especially important in applications where the breaker is frequently used as a switch, such as in motor control circuits or lighting control systems. Switch duty rated breakers are designed and tested to withstand the mechanical and electrical stresses associated with frequent switching operations. There are several factors that differentiate AIC rating from switch duty rating. Firstly, AIC rating focuses on the breaker's ability to interrupt very high fault currents during abnormal conditions like short circuits. Switch duty rating considers the breaker's ability to withstand repeated switching operations under normal or slightly overloaded conditions. Secondly, AIC rating is primarily related to the thermal and magnetic effects of high fault currents and the breaker's internal components, while switch duty rating is concerned with the mechanical wear and electrical contact degradation resulting from frequent switching. Thirdly, AIC ratings are determined through standardized testing procedures that simulate fault conditions, such as short circuits with specific current levels and durations. Switch duty ratings are established through testing protocols that involve repeatedly switching the breaker on and off under specified load conditions, evaluating the breaker's performance and lifespan. A breaker might have a very high AIC rating, making it suitable for applications with high fault current potential, but it might not be designed to withstand frequent switching operations. Conversely, a breaker might be switch duty rated, meaning it can handle frequent switching, but its AIC rating might be relatively low, limiting its ability to interrupt very high fault currents. Therefore, it's essential to consider both AIC rating and switch duty rating when selecting a breaker for a specific application. If the application involves frequent switching, such as in motor control circuits or lighting control systems, a switch duty rated breaker should be chosen. If the application requires the breaker to interrupt high fault currents, a breaker with a sufficient AIC rating should be selected. In many cases, breakers are designed to meet both AIC and switch duty requirements, providing both robust fault protection and reliable switching capabilities. Electrical standards, such as those developed by underwriters' laboratories, specify the testing and performance requirements for both AIC and switch duty ratings. Breakers that meet these standards are marked with the appropriate ratings, allowing engineers and electricians to select the right breaker for the application. The selection of an appropriate circuit breaker depends on several factors. These factors can include the prospective fault current at the point of installation, the normal operating current of the circuit, the frequency of switching operations, and the environmental conditions. Consulting with a qualified electrical engineer is recommended to ensure the correct breaker is selected and installed for any application. Misapplication of a breaker can lead to safety hazards and equipment damage. The consequences of using a breaker with an insufficient AIC rating can be severe. If a fault current exceeds the breaker's AIC rating, the breaker might fail to interrupt the current safely. This could result in arcing, explosion, or fire, posing a significant risk to personnel and equipment. The consequences of using a non-switch duty rated breaker in an application that requires frequent switching can also be problematic. The breaker's contacts and operating mechanism might wear out prematurely, leading to unreliable operation or failure. This could result in downtime, equipment damage, or even safety hazards. The purpose of the ampere interrupting capacity (AIC) rating is to specify the maximum short circuit current that a circuit breaker or fuse can safely interrupt. If a fault current exceeds the AIC rating, the device may fail catastrophically, resulting in severe damage or injury. Switch duty rating specifies the breaker's ability to repeatedly switch normal load currents. Switch-duty rated breakers are designed and tested to withstand the mechanical and electrical stresses associated with frequent switching operations. The Institute of Electrical and Electronics Engineers (IEE) and the National Electrical Manufacturers Association (NEMA) are two organizations that publish standards related to circuit breakers and their ratings. The standards outline testing procedures and performance requirements for AIC ratings and switch-duty ratings. Circuit breakers are protective devices designed to interrupt fault currents and prevent damage to electrical equipment and wiring. A circuit breaker's ability to interrupt fault currents is determined by its AIC rating, which represents the maximum current the breaker can safely interrupt without failing. When a fault occurs, such as a short circuit, a large current flows through the circuit. The circuit breaker must be able to quickly and safely interrupt this current to prevent damage. If the fault current exceeds the breaker's AIC rating, the breaker may not be able to interrupt the current effectively, leading to potential hazards. AIC ratings are typically expressed in thousands of amps, such as 10,000 amps, 22,000 amps, or 65,000 amps. The appropriate AIC rating for a circuit breaker depends on the potential fault current at the point of installation. Electrical codes, such as the National Electrical Code (NEC), provide guidance on how to determine the appropriate AIC rating for different applications. Switch-duty rated breakers are specifically designed for applications that involve frequent switching of electrical circuits. These breakers are built to withstand the mechanical and electrical stresses associated with repeated opening and closing operations. Switch-duty ratings are typically indicated by a lettered designation such as SWD, which stands for switching duty. Switch-duty rated breakers are commonly used in motor control circuits, lighting control systems, and other applications where frequent switching is required. These breakers are designed to provide reliable performance and extended lifespan under demanding switching conditions. The selection of an appropriate circuit breaker involves considering various factors, including the AIC rating, switch-duty rating, voltage rating, current rating, and enclosure type. Electrical engineers and electricians carefully evaluate these factors to ensure that the selected breaker meets the specific requirements of the application. Regular inspection and maintenance of circuit breakers are essential for ensuring their reliable operation and safety. Circuit breakers should be visually inspected for signs of damage, such as cracks, corrosion, or overheating. The breaker's terminal should be checked for tightness, and the breaker's operating mechanism should be tested to ensure it functions properly. Circuit breakers play a critical role in protecting electrical systems and preventing electrical hazards. Understanding the different types of circuit breakers and their ratings is essential for ensuring electrical safety and reliability. Consulting with a qualified electrical professional is always recommended when selecting, installing, or maintaining circuit breakers. This helps ensure that the correct breaker is chosen for the application and that it is installed and maintained properly. Several factors contribute to the overall performance and lifespan of a circuit breaker. These factors include the quality of materials used in its construction, the design of its internal components, and the manufacturing processes employed. High-quality circuit breakers are designed to withstand the stresses of fault currents and switching operations, providing reliable protection and long-term performance. The interrupting rate of a circuit breaker is a measure of its ability to safely interrupt a fault current without being damaged. This rating is typically expressed in amps and indicates the maximum current that the breaker can interrupt at its rated voltage. The interrupting rating of a circuit breaker is an important consideration when selecting a breaker for a specific application. The breaker's interrupting rating should be equal to or greater than the available fault current at the point of installation. The available fault current is the maximum current that could flow in a circuit during a fault condition such as a short circuit. The electrical codes and standards provide guidance on how to calculate the available fault current for different types of electrical systems. Circuit breakers are available in a variety of types and sizes to suit different applications. Common types of circuit breakers include thermal magnetic breakers, magnetic-only breakers, and electronic trip breakers. Thermal magnetic breakers are the most common type of circuit breaker and are used in a wide range of applications. These breakers use a combination of thermal and magnetic elements to trip the breaker in response to overloads and short circuits. Magnetic-only breakers are used in applications where fast tripping is required, such as in motor circuits. These breakers use a magnetic element to trip the breaker in response to short circuits. Electronic trip breakers are used in applications where precise control of tripping characteristics is required. These breakers use electronic circuitry to monitor the current and voltage in the circuit and trip the breaker when certain conditions are met. The voltage rating of a circuit breaker is the maximum voltage that the breaker is designed to operate at. The voltage rating of a circuit breaker should be equal to or greater than the voltage of the circuit to which it is installed. The current rating of a circuit breaker is the maximum current that the breaker is designed to carry continuously without tripping. The current rating of a circuit breaker should be selected based on the load that the circuit will be serving. The enclosure type of a circuit breaker refers to the type of enclosure that the breaker is housed in. Circuit breaker enclosures are available in a variety of types to suit different environmental conditions. Common types of circuit breaker enclosures include NEMA 1 enclosures, NEMA 3R enclosures, and NEMA 4 enclosures. NEMA 1 enclosures are designed for indoor use in dry locations. NEMA 3R enclosures are designed for outdoor use and provide protection against rain, sleet, and snow. NEMA 4 enclosures are designed for indoor or outdoor use and provide protection against dust, water, and ice. Circuit breakers are essential components of electrical systems, providing protection against overloads, short circuits, and other electrical faults. Understanding the different types of circuit breakers, their ratings, and their applications is essential for ensuring electrical safety and reliability. Consulting with a qualified electrical professional is always recommended when selecting, installing, or maintaining circuit breakers. This helps ensure that the correct breaker is chosen for the application and that it is installed and maintained properly. The AIC rating of a circuit breaker is a critical parameter that determines its ability to safely interrupt a fault current. The switch duty rating of a circuit breaker is another important parameter that determines its ability to withstand frequent switching operations. When selecting a circuit breaker, it is essential to consider both the AIC rating and the switch duty rating to ensure that the breaker is suitable for the application. Regular inspection and maintenance of circuit breakers are essential for ensuring their reliable operation and safety. Circuit breakers should be visually inspected for signs of damage, and their terminals should be checked for tightness. The breaker's operating mechanism should be tested to ensure it functions properly. Replacing damaged or malfunctioning circuit breakers is essential for maintaining electrical safety. The electrical system should be inspected and maintained regularly to ensure that all components are in good working order. Electrical safety is a shared responsibility, and everyone should be aware of the potential hazards associated with electricity. Following safe electrical practices can help prevent accidents and injuries. Circuit breakers are designed to protect electrical circuits from damage caused by overloads or short circuits. Firstly, circuit breakers work by interrupting the flow of electricity when a fault is detected. Secondly, the interrupting capacity of a circuit breaker is the maximum current that it can safely interrupt. Thirdly, switch duty rated circuit breakers are designed to withstand repeated switching operations. So it is essential to select the correct circuit breaker for the application to ensure electrical safety and reliability.